You should have your Day 7 Pythagorean Theorem notes out in front of you as we go over this slideshow. If you do not have your notes, please take out a piece of paper. If you forgot to do your notes, but you still have the skeleton notes copy, you can take that out and try to fill things in as we go. So this is Day 7 Pythagorean Theorem. A couple things to kind of get out of the way before we get started. So first of all, a right triangle looks like this. And what makes it a right triangle is the right angle box that's in the corner right here. If it does not have that little box, it means it's not a right triangle. And a right angle is 90 degrees. So a right angle or a 90-degree angle are the same thing. A couple more definitions. You don't have to know these words necessarily, but you need to know how to use them. So in a right triangle, across from the right angle is called the hypotenuse. Okay, it's the longest side. It is always across from the right angle. The other two sides are called legs. Okay, so they're the shorter sides. Okay, so the most important thing to know is that the longest side is across from the right angle. Now, the Pythagorean theorem itself is used to find the length of the hypotenuse or the length of the legs in a right triangle. So any of the missing sides you can find by doing the Pythagorean theorem. So what's really important to know about this is, first of all, here's the Pythagorean theorem. A squared plus b squared equals c squared. And in a right triangle, the sides are labeled like this. A and B are the legs, and then C is the side across from the right angle. So that's the most important part. A and B can be switched around. Doesn't matter what order you do that part in, but because in the Pythagorean theorem, C is on one side of the equal sign all by itself, it has to be the side that's across from the right angle or the hypotenuse. Okay, remember that means the same thing. C is the hypotenuse, it's the side across from the right angle. So now we're going to get into actually doing a problem using the Pythagorean theorem. So this example was in your notes. It says find the length of the hypotenuse. So we have this triangle. We don't know the longest side right here, but we know 1.5 is a leg and we know 2 is a leg. So we're going to plug in what we know. So first of all, the side across from the right angle is C. That's the part we don't know. So A could be 1.5 or B could be 1.5. It doesn't matter. Okay, so we're going to do 1.5 squared plus 2 squared equals C squared. Okay, so on your calculator, we're not multiplying by 2. We are squaring it or multiplying 1.5 by itself. So 1.5 squared is 2.25. 2 squared is 4. And then we still don't know what C squared is, so you just write it down. So now you're basically doing train tracks. 2.25 plus 4 is 6.25, but that's what C squared is. We don't want C to be squared. We just want C by itself. We talked about this in our last unit, that the opposite of squaring something is to take the square root. So if we do the square root, that will just get us C by itself. So that means we also have to do the square root on the other side. So the square root of 6.25 is how we get our answer. So C equals 2.5. You will always have a square root to do at the end of this process. All right, so I'm going to jump ahead to the check for understanding problems that you had to do on your own. So I'm going to switch here to our document camera, and we're going to talk about this. So the first problem said, can the numbers 12, 16, and 18 be the sides of a right triangle? All right, so let's jump back to here, and we're going to draw what that would look like. So first of all, draw a right triangle. Let's just assume that it works. So here's our right angle. So we're talking about the sides 12, 16, and 18. Let's make this a little more clear, sorry. Okay, here we go. So we have 12, 16, and 18. 18 is the longest side. Remember that the hypotenuse is always the longest side, and the hypotenuse is across from the right angle. So we would put 18 here. And then for 12 and 16, it doesn't matter which one is which leg. So I'm going to put 12 over here and 16 over here. Now, just because we've drawn a right triangle and we've put some numbers on there does not mean that it's actually a right triangle. In order to be a right triangle, these numbers have to satisfy this Pythagorean theorem. So we have to do a squared plus b squared equals c squared, and it actually has to be equal. If it's not equal to c squared, it's not a right triangle. Okay, so going back to our picture, c squared is the one that you need to start with. So c is the side across from the right angle, the hypotenuse, which is 18. Okay, 12 and 16 could be a or b or vice versa. It doesn't matter. So I'm going to say that a is 12 and b is 16. Okay, so now we're just going to plug all that into the Pythagorean theorem. So a is 12, so 12 squared. B is 16, so 16 squared. C is 18, so 18 squared. Okay, we want to know, is this equal? We're not sure yet. Okay, we have to do the math and figure it out. So we're going to do train tracks. So 12 squared is 144. 16 squared is 256. And again, we want to know, does that equal 18 squared, which is 324? Okay, if we add these two together, 144 plus 256, we get 400. Is 400 equal to 324? No. So that means these three numbers cannot be the sides of a right triangle. All right, the second problem that was on your check for understanding was number 2. It says Marcos walks 3/4 of a mile east and 1.8 miles north to school every morning. If instead he walked in a straight line from his home to his school, how many miles would he walk? So what it's saying is, instead of going, 3/4 of a mile this way and 1.8 miles this way, what if he just walked diagonally? That's what this dotted line is for. Okay, so I'm going to switch back to our document camera here. So this is our same picture. Here's his house, here's his school. We're trying to figure out this side right here. Okay, so the first thing you need to do is label A, B, and C. Okay, since this is across from the right angle, this would be C. Okay, now 1.8 could be A or 3/4 could be A, it doesn't matter. I'm going to turn 3/4 into a decimal, so 0.75, and I'm going to say that that's A, and 1.8 is B. So now we're going to use the Pythagorean theorem. So we have to do 0.75 squared plus 1.8 squared equals C squared, because we don't know what that diagonal distance is. 0.75 squared is 0.5625. You just need your calculator. Okay, 1.8 squared is 3.24, and we still don't know C squared, so now we're going to do train tracks. So I'm going to add these two together. That equals 3.8025, but that's still C squared. If we just want C by itself, now we're going to do the square root. So the square root of 3.8025 is 1.95. So that would be what C is. Some of your calculators, when you do the square root of a number, like let's say we're doing the square root of 36, it will just say your answer is the square root of 36. Let me see if I have one of those calculators. So it looks like this. So if I'm going to do the square root of 36, first of all, on a lot of the calculators, you need to push second and then another button. So on this one, the square root button is right above the x squared button in green. That's why you need to push second. So I'm doing second x squared, and then let's just put in a number that's that is a perfect square, so 36. Okay, so that equals 6. That's a pretty straightforward one. If you do the square root of something that's not a perfect square, like 30, if you just push equal, it might say the square root of 30. What you need to do at that point is push this little double arrow button that's right above the equal sign. So when you do that now, it converts it to a decimal. That's what you want. You want that decimal. And it's okay if you round. You could just round to the nearest tenth. So in this case, I would say 5.5.